My name is Michael Smith, and I'm now the Director of APAC Interconnection for Netflix. I've been working on internet engineering since about 1995. Started with a regional ISP in the northwest of the United States, back when there were regional ISPs in the United States. And then spent time building a large-scale network for rural households. It was about 10,000 kilometers of fiber, specifically designed to connect people that had not been able to connect to the internet before we put the network in. Also did some work with data center engineering and design, and finally, for the last 5 years or so, I've been working solely with CDNs. I worked at Edgecast Networks that then became part of Verizon Digital Media Services, and now work with Netflix on our Open Connect product, which is the CDN. So, kind of wanted to start with the way that we see the internet in India. But Netflix has been in India now for about 19 months. And when any particularly US company comes, what do we hear about, what's it going to be like to be a company coming into India? And without fail, this is what we see. This is what we hear from everybody. Oh, it's awful. You're never going to be able to get connectivity. It doesn't stay up. All of these things that we hear. So this is the vision that everybody has in their minds internationally of what the network is like. And it's all about extremes. It's very hyperbolic, right? Everybody's talking about how, oh, it's so bad. So we have data. And we wanted to say, well, what is the network really like in India? And what we found, so we wanted to show, and I'm sorry, I'll get to this in just a sec. First, how do we measure that network performance? And we have kind of 4 values that we use. The first is per subscriber throughput. And that means when you're sitting on whatever device you're using, if it's a mobile phone, television, whatever, how much data can you get to that to actually stream Netflix services? The second is TCP retransmits, which is part of the protocol that runs the internet. Retransmits means that we have to resend the data. So that means that there's some other problem somewhere in the path between source and destination that's causing an issue. The third is network congestion at a provider level. So when we look at each of the hops that it has to go through, are we experiencing some kind of network connectivity issues? And then the fourth is what we call median play delay, which is when you press play, how long does it take to actually start the video once you press play? For this discussion, I'm just going to focus on per subscriber throughput and median play delay. They're the easiest that we can look at and kind of cross. You don't have to be purely an engineer to understand the values that we associate with these. So I thought it would be best to look at 2 markets in comparison, because we could just look at India, but then we don't have a basis of comparison. Brazil, in a lot of ways, is very similar to India, but on the Netflix side, Brazil has been on our service for over 5 years, whereas India has only been on the service for 19 months. And so it's a good comparison to see kind of, are they the same, are they different, what will they look like over time? Just from a numbers perspective, this is the way that we view the market. And really from a Netflix perspective, the 18.8 million broadband households is where we focus. The 4G number is very hard to pin down in India, as you know. There's been a lot of movement in the 4G space. And so we kind of put it at 124 million. We've heard 150 million. We really don't know what that number is. But as you can see, it's almost double what mobile looks like in Brazil. Honestly, from a Netflix perspective, most people view Netflix from computer screens and larger. The actual amount of viewership when people are actually viewing it on their phones, on their mobile plans, is very low. So we tend to focus all of our efforts on what's happening in the what we call the broadband household sector. Now, our ISP speed index is something that we publish globally. It's available to anyone. And people are added to that when they become a service provider that have enough view hours that we can actually monitor them in comparison to other providers in the market. As I was saying before, we don't monitor mobile, and we don't monitor what we call our SD plan, which is the very lowest plan. The assumption being that people that are using those are going to get artificially low speeds. And we don't want the provider to be penalized because they have people that are using a service that by its very nature is lower than what they can possibly achieve. We're trying to set a high benchmark for providers. So when we look at this for Brazil, and it is a little small there, but I can tell you that that number on the left-hand side there at the very top is 3.2. So that's 3.2 megabits per second. And down at the bottom, if you look at the very lowest trough, I want to say it's at about 2.2. The important characteristic here is that 3.2 megabits per second as an average speed, that means if you're sitting on the very largest TV that you can buy, you can watch an HD stream and it will look the same quality as if you were basically getting 16 megabits per second. You would not notice any degradation in service. So that's basically the top of the line at 3.2 megabits per second for average. So given what I was talking about before in India, we would assume that there are no providers at 3.2 megabits. We would assume everybody's down low given that hyperbole that we talked about before. And in fact, that's not the case at all. Today, we have providers that are at 3.2 megabits per second already in India, and that's only after 19 months. So what we're finding is that a lot of that discussion around where networks are in India is really about where networks were in India. We're seeing a lot of growth and maturation and increases in performance and quality of networks across the country. Sorry, that's the comparison so you can see. Now, the other thing you can see in the graph, and I'll show it to you here, this is what performance has looked like since the beginning of time. And again, this is showing the providers that have been available. This is fiber to the, I shouldn't say, it's the broadband households, providers that have it. And you can see that the increase, even for, let's take the top one for SpectraNet, went from below 2 megabits per second up to 3.2 megabits per second. In many of these cases, that's a result of the relationship that we have on the CDN side. So CDNs enable us to actually increase the performance of networks and as we'll get into this, by moving the content closer to the eyeballs. And then on the play delay side, play delay is very important from a user kind of perception perspective. When you click on that play and you have to wait, that's the thing that everybody knows. They're just kind of like, oh, I really want to watch this movie. And you can see this is what the play delay looked like in Brazil, which is in the orange, and then in India in the blue. And I took it for the first 19 months of both services to give a comparison. And you can see that they're almost exactly the same. So what we saw in Brazil and what we see in Brazil today, I think we're also going to see in India. This is the play delay today. And as you can see, it's very similar. Right now, there's still a little higher play delay on average in India, but we expect that, remember that those first ones I showed you for the first 19 months, in the case of Brazil, that was 5 years ago, and so we have no doubt that these numbers will continue to merge, and in fact, we believe India will continue to get better over time. So what we expect, consistent growth in viewing. There's going to be a robust competitive OTT environment. We'll continue to see increasing interconnection options. And as always, network performance is getting better and better. So this is our crystal ball look into what's going to happen over time. So let's move a little bit into the CDN side of the house, since that's kind of what I do on the engineering side. So what is a CDN? And there's a lot of discussion around this, because a CDN is used as a term like cloud. What is a cloud? And jokingly, when we talk about on the engineering side, we say a cloud is somebody else's computer, right? It can be anything. It doesn't matter. It's just it's a marketing term that was coined to make a very difficult concept simple, and CDN is very much the same way. There is no real definition of CDN. What I consider to be a CDN that works for Netflix is very different than what someone would consider a CDN that works for Akamai. It's not a global term that's recognized. It's just a concept. And the concept that I like to use is a scalable platform for increasing consumer quality of experience by maximizing the network efficiencies of moving content closer to the user. It took me hours to get this into a single sentence. I'm really proud of this one sentence. But basically, it's a platform, and that platform could be anything. It could be some certain set of servers. It could be a combination of server and network. It could be a particular type of delivery if you're using DNS versus what we call Anycast. There's all of these different things come together to create the platform, and that platform is amorphous. But really what we're trying to do is increase the quality of experience by moving the content as close to the user as possible. Now, why are CDNs important? Now, okay, so this, how many people know the dancing baby? A few. We're all showing our age here. So the younger folks will not necessarily know the dancing baby. In 1997, this dancing baby came out. It was a 3D graphic that was created by a video house in the United States. And everybody jumped on this and started to put music to it, put the baby in scenes, and it became the first internet meme. Now, this is at a time when most people were connected to the internet over dial-up modems. And those dial-up modems were then connected to lots of little ISPs that connected on and so forth to the larger ISPs. Because of the sheer amount of traffic that this generated, it caused the internet to slow for most people globally for some periods of time, where before they had never experienced that before. They'd always had a fairly clean pipe to the internet. This caused a massive amount of congestion that nobody had expected, and nobody really knew. It forced a new idea. What are we going to do to deal with these types of massive increases in traffic? So this is what the internet looked like in 2000. Very small. And the focus here is, if you look in the core, the red, it's not very dark, right? There's not a lot going on. And so when you throw a massive amount of data at this very, let's just call it spindly looking internet, it's very fragile. And there's a lot of places that it can break. Now, in 2000, again, there were eyeball networks. Those are the ISPs. You had transit service providers providing access, very few of them. There was not a lot of peering. If I was a small ISP, my ability to connect directly to other providers was very limited. There was also a very clear-cut distinction between services. As an ISP, I wasn't a video provider. I wasn't a content provider. Everything was very separated. Then as we move today, and for CADA, this is 2015, now you can see what the density looks like. The core of the internet is massive, and you've got this huge proliferation of service providers out to the edge. There are lots of peering options, so the ability to interconnect has grown exponentially. However, the number of ISPs that you have now at the edge has gotten smaller and smaller. Now, the two countries where that is still not as much the case are Brazil and India. In Brazil, there are over 2,000 small ISPs. In India, there are over 600. When you start to look at other places like the United States, most of the countries in Europe, a lot of the countries in Southeast Asia, when you're talking about the number of service providers that you can get to provide service at your home, you're down to 5, 4, 3. In the case of the US, normally 2. And so there's been this massive consolidation. And the other thing that's happened in a lot of these markets is those 1 or 2 providers that are providing those network services are also now competing to provide you the content that rides on those services. And that's the big difference of the internet now, is the consolidation not only horizontally of networks, but also vertically of the services over the networks. That's the least engineering thing I'll talk about, I promise. So we have massive growth, we've got these new ideas, and CDNs are born. So in 1998 was the first, and that was Akamai. And actually Akamai, there's a meeting in the United States called NANOG, and a bunch of their engineers had gotten together and were talking about the scaling problems. And then you had PhDs coming out of MIT and some of the other universities in the Boston area that said, hey, we think we've got a way to solve this. And so they came up with their particular version of this. But I can tell you, as the service provider that was showing that dancing baby in 1997, when we heard about Akamai, because Akamai from the get-go said, you can put our servers in your network, we had their servers in my small regional ISP, we had their servers in our network within, I think, 9 months of their starting business. And that was the case all over, because everybody wanted a way to get that traffic out of the expensive pipes that were going back towards the center of the internet and get it as close to the edge as possible. And then, of course, after Akamai started to get successful, lots of other people came into the market. Limelight was the next in 2001. And then beyond that, you had Edgecast, which became Verizon, BitGravity, which became Tata. Level 3, they actually had also purchased another CDN. Cloudflare, which is still around, and Fastly, which is still around. And there are some other smaller ones as well. But suffice it to say that the idea of moving the content to the edge became very popular. and created business models that were successful for multiple companies. Now, in some cases, when you get to a particular scale, and that scale is not, there's no magic number, it really depends on specifically what your application is doing and what your content is. There are certain companies that realized that even using the commercial CDNs was not going to scale to the levels that was required to be able to maintain the quality of experience that you needed for the users. Netflix, obviously, we're one. Google is the other one. Really the first, and this is my personal opinion, the first one to do it was Microsoft, because even back from Windows 95 and on, Windows Update, you can imagine all of the users globally that need to download software updates, that came through windowsupdate.microsoft.com, which was actually a CDN that Microsoft had put in across the globe. So how do CDNs work? Now this is, okay, this is the one where we hope my animation works, because it was done on a Mac, so we'll see if this works. How many, if I can get a show of hands, how many people are actually, are engineers as part of their primary focus of their job? I apologize in advance, this is going to seem very sophomoric. This is a very simplistic view of how this works. So I'm sitting at home, and in this case I want to watch a movie on Netflix, and so I've selected and I press play. What happens? Well, the server that I need to go to, this is the without CDN case, is going to be sitting in the US somewhere. So in order to get to that server, first thing I'm of course going to go to my local wireless or wired modem. That's going to go to my local ISP, if I can press, there we go. Now in the case of India, that local ISP, in all likelihood, unless I'm using one of the large providers, won't have the ability to connect directly internationally because of regulations, right? They're just not allowed. So they're going to go to another ISP that has that capability. Now in most cases, as an example, let's take Tata. So Tata has VSNL, which is local, and then they've got Tata, which is their international. And so for them to go from VSNL to Tata is actually another hop. And then Tata would send that traffic to the provider that's in the US, also a global carrier that has usually access to undersea capacity. They would then go to a smaller regional ISP. They would then go to the hosting company that serves that server. And finally, we've gotten to the content. Now, of course, that path has to be followed forward and back for every piece of content that is requested. And as you can imagine, not only the points of failure that are available, but then you have to make sure that every one of those hops has the ability to serve as much traffic as possible. Now, the other complication is when you get into the center of the internet, that one-to-one relationship is questionable at best. There could be a fiber outage. There could be a peering argument that people are having where a path that was available today is no longer available. And so the number of providers that you actually probably have to go through in the middle can be any number from one to many. Now, if we do it with a CDN, that's it. So you go to your modem, you go to your local provider, there's a server that's local on the network, it goes to the server delivers the video traffic. That's really what the CDN provides. So all of the things that happened previously, all of those are removed from the equation. Now, we do still have to get traffic, we have to get what we call the cache fill, the ingest to the server, but that's something that happens at a much smaller rate in comparison because the CDN is able to take whatever content it has and amplify its ability to send that traffic. So 1 gig of cache fill can become any number of hundreds of gigs of data to the end user. Now CDNs provide efficiency through path, I think, okay. Sorry, I didn't know which version we had. So the efficiency through path minimization, which is what we just showed. The number of hops that it takes to get from source to destination is significantly reduced. The quality of experience is increased by reducing latency and loss. The amount of latency is how long it takes to get from one end to the other. That is significantly reduced by putting the servers as local as possible. The loss part is an unknown part of the equation because loss happens, it's not definable. It may happen, it may not. You could have someone who's running their undersea capacity at 100%, and so when you try to send just a little more traffic, you end up with congestion. That's the kind of thing that we're guarding against by using the CDNs. There's cost efficiency by eliminating inter-provider links. So if I'm a service provider and I've got the cache servers on my network, the comparison is, let's say I've got 10 gigs of traffic. That 10 gigs of traffic, as far as being able to deliver it across the internet, is now essentially free for me in comparison to what I would pay if I had to pay my transit provider to provide that 10 gigs of service to me. And what it really provides is internet stability. If you think about it, the OTT services in general, and Netflix, I think the published or quasi-published, is in the United States we're responsible for about 37% of internet traffic at peak. And if you add Google in, then you're talking about 85% of traffic, and then you add everybody else in. As those numbers continue to increase, the ability of the core of the internet to support all of that traffic really becomes suspect, because being able to get it from country to country, moving from provider to provider, all of those things require inter-provider links that are not guaranteed. All of those links are created through business relationships and commercial relationships or peering relationships. There is no guarantee that any of that will occur. And so when we try to push more and more traffic across the core, we're requiring the infrastructure to be there whether or not it is or not. So we try to avoid that by localizing the traffic, because then the only relationship that's really required is the one between the end service provider and the CDN provider. And it frees up the rest of the internet to handle all of the other traffic where a CDN doesn't make sense. So this is a little hard to see. This is just a little compare and contrast. So this is a Traceroute. And for those of you that aren't familiar, this shows a path a packet takes across the internet, and basically the latency involved. So I was in the hotel this morning, and I just traced to a site in Seattle. And if you look at this, the Traceroute here, the first basically 10 hops or so go through Tata, through VSNL, and then to their global network. Then it hops over to NTT, then it goes over to a provider called Spectrum, and then it goes to the Seattle IX, and then it goes back to a provider called Spectrum. So there's all of this is what it takes to get to a site that is not CDN enabled. And so you can imagine, if I have to send 100 gigs of traffic across that link, I have to deal with every one of those hops and hope that they're all able to carry my 100 gigs of traffic. I can tell you, if you look at hop 8, and this is a rough indicator only for the people that understand Traceroute, you can see those two little asterisks there. That usually means that router was so busy processing other traffic that it wasn't able to process the Traceroute command. It's not an indication of path loss. It can be an indication that there is a lot of traffic and busyness on that router. So you can imagine throwing more and more traffic against those sites. Now let's look at that in comparison to an Akamai connected site. So this is going to airtel.in from the hotel. And it's 7 hops, but if you think about it, it's actually only 1 hop, because hops 1 through 6 are all VSNL. And then this is obviously a server that is on VSNL's network. And that's it. So I go from my hotel to the Akamai server, boom, and I'm done. So this is when I was talking about the compression, how it looks. So if you've got an ISP network where we are but one of many and there's no CDN involved, and as an example, if we have 350 gigs of traffic, you would need about a terabit of capacity to handle that, because you would have to also handle all of the other traffic involved. Whereas if you've got CDN servers on your network, the amount of capacity that you need is functionally 0. So in our case, and again, it varies from provider to provider, it takes anywhere from 500 megs to 1.5 gigabits to entirely fill the cache. And that can serve any number of terabits of traffic. It doesn't matter. Now, what CDNs don't provide, right? So there is no traffic prioritization that comes with a CDN. The CDN doesn't give the provider the ability to say CDN bits are more important than non-CDN bits. There's no traffic priority. There's no quality of service increase. There are no functional benefits that come to the CDN provider or the CDN bits over any other. We consider all bits to be the same across the network. The CDN bits, the only thing that they have is an increase in efficiencies that come from being closer to the user. They don't get any added benefits from being on a CDN than you would get from not being on a CDN, aside from the technological ones that we talked about earlier. There are no the big CDNs. If you're a very, very small provider, so let's say you're a cable company with 10 users or 100 users, the cost of putting the servers on the network, the cash flow that I talked about, those are actually more expensive than it would be just to provide that service over transit. And so there's an economies of scale that happen. So very small providers are still benefit from just using normal transit internet service that they would normally use. And then they'll get to a point where they say, well, if I add a server, here's the cost to add that server, and now that makes more sense than what I was paying for transit before. Oh, this is going to go a lot faster than I actually thought it was going to go. We'll have plenty of time for questions and discussions. So this is, again, our crystal ball. The way that we think the internet is going to kind of evolve. We're going to see traffic just continue to grow. I don't think video is the end of what will be the big drivers for growth. We are, in fact, going to see, obviously, and we've seen this in India, massive growth of mobile. And really kind of what I think about when I think about mobile is not so much the fact that you've got mobile as far as the users on the phones, because with video, there's going to be a continued increase in that, but video is just not as interesting on small phones as it is on larger services. But the technologies that are coming into play for actually using mobile services to deliver all the internet versus using fiber to the home or continued use of existing copper services, as we move into 5G and whatever is beyond 5G, I see a future where rather than having to be connected at my house from fiber, I'm on my phone, I'm doing whatever I'm doing, I get home, I put my phone down, my 5G connection is now automatically connected to my television, I turn on my TV, I watch TV. This all happens over the air, and I'm no longer connected physically the way that I used to be. That's my personal hope, anyway. There's going to be lots of, I think, and we've seen, if you think about 10 years ago, nobody thought that we could even do video over the internet. And so I do believe that most entertainment sources that we see will ultimately end up moving to the internet. Not to say that movie theaters are going away, but I do think that most people will find the majority of their entertainment online. There are lots of also non-entertainment functionality that will continue to increase, which includes education. We've got the ability to do remote video, and for classrooms, there are some countries, particularly if you think about like Turkey, that are doing a lot to try to make that the way that people are educated. Telemedicine is another one. When you think about a single x-ray is about 5 gigs, and so to be able to transmit that from anywhere and have it diagnosed by a doctor that happens to be 1,000 miles away, I think that's also going to increase. We're still in the early stages of the development of that. And then who knows with things like virtual reality and all the other stuff, what's going to happen. And of course with all of the Internet of Things, and that's all a mystery at this point. Now, if the mobile thing comes true, then we're also talking pretty much about ubiquitous access, because being able to put in cell towers is a matter of time and money versus being able to extend fiber to every single person on the planet, which is nigh on impossible, right? The airwaves, not free, but the airwaves are certainly more accessible.